Hello everyone. Have you had a good day so far?
Yeah, nice.
It's gonna get better now. No, but my name is Andelkovic. I work as an agile testing lead at King. Do you know King, the company?
Sure.
So I'm here today to talk about a little bit of a journey that we have done at King with artificial intelligence. How about it, artificial intelligence? Are you guys aware of it, or is it new, totally new for you? Okay, so if you have any questions, just raise your hand and I'll try to answer them immediately. And if you're too shy or whatever, you can ask me afterwards, and I'll be glad to talk about the presentation. And also if you're curious about the company in general, stuff like that. And also if you hate or love our games, so I can try to be as polite as possible. All right, so King is a Swedish company. It was founded in 2003, and it did like web games in the beginning for the web. And when Facebook and mobile was big, I think the company was lucky to be able to release a game that still today are like the most popular game in the world. And we have like 2,000 employees. The company has made like over 200 games. We are like in 13 different studios around the world, and we got acquired by Activision Blizzard 2016. And yeah, it's been an interesting journey, I would say. So the company's focus are not to mass produce games. The aim is more to find games that will last for 5 to 10 years. So that's our focus. So the bar is quite high when it comes to what are we going to release to our customers. And one thing that we have learned over time that are important are quality. So you need to have good quality in the game. The functionality should work, not crash that much. The graphics should be like really nice, and then the gameplay should be like easy and easy to get started and stuff like that. And so what we have done is that we built up like a different franchises, and Candy Crush is the most popular, but we have other franchises. So I think we have around 15 games now that we are maintaining. And a challenge maintaining these games are quality. So the way we do quality at King are that all of the games, they're responsible for their own quality. So what they can do, they can choose from a pool of different QA roles. Here's a list of them. ATL, that's like a test lead, and the person's goal is to be an ambassador for quality in the team. So it's not that person that do the testing. It's more that person talking to the developers and telling them like, you need to test your code before you ship it. So it's like a collaboration, I would say. And then we have QA analysts. They're more like exploratory testers. So what they do is that they sit together with the developer and test new functionality when they have coded it before they check in the new things. So we're trying to build this, I would say, awareness that you shouldn't just ship stuff that you're not proud of or can clean up yourself. So it's really important for them to think about that. Another thing that we have at our company is a quick regression team, and what they do is that they regression test our games. So when we launch a game, we have teams that test through the whole game. So they have like 1,000 to 1,500 test cases that they need to run through in 6 hours. And they usually give valuable feedback. Test automation engineers, that's something that we have also. What they do is mostly build automation frameworks for the game teams to use. So they're not the guy that are doing all of the automation works themselves. So they're like, usually talking a lot to the developers and also the testers in like, okay, we want this functionality in the automation frameworks. And then we have, our games are like data driven. So what that means is that what we do is that we measure what everything we do. So what we do is that when players are playing our games, we're monitoring their behavior and actions, and then we analyze and base future business decision on the learnings we get from looking at our users, what they want. Of course, we listen also to people that send in requests and stuff like that. But we can see quite quick with the numbers what people like and not. So, and it can be like a big difference. You can release a game with a blue button and a red button, and you might have like 80% loves the blue button and not the red button. So there's like a no-brainer. Okay, use blue buttons, not red buttons. So the data scientists, they're also testing, but they're testing more the data. So the data needs to be also like checked that it's okay, so that we can trust the data. So they are also like doing QA work, I would say. And then we have the developers. So they are also, helping out with testing, and that's super good because, yeah, they're the one that are usually, in most cases, creating the bugs. And so it's good if they, take ownership of their own work. And so any questions on this? Yeah?
And you told about the quick regression teams that they have like a lot of test cases in like 6 hours or something. And we all know that like advertising is the main thing in the games. And so they like going through the advertising purchase funnel, or they test the game in whole.
So the question were if this quick regression test teams, if they test everything or specific things.
Yeah, right.
And I would say they test everything. So it's we do like for every area we have like a smoke test, or like this needs to work. So that's the thing that they test first. And then if there's no issues and they have time over, then they usually do exploratory testing to see if they can find edge cases or strange behaviors, stuff like that. Yeah. Yeah. Any other questions around this, the testing part? All right, I continue then. All right, so Candy has more than 2,000 levels, and for every quick regression test team, we need to make sure that all of this level works. So it's a big challenge because there are more and more levels, more and more games, and we love the quick regression test team, but they need to have a life. So we've been thinking like, how can we help them to make their life a little bit easier? So what we have done then are like this started like 2 years ago. This journey, we have explored artificial intelligence. So I'm not sure if you know who these two guys are, but the guy on left, he was like a world champion in chess, and he got beaten by like an IBM computer, like, was it 20 years ago, something like that. And this is the latest victim for AI. He's like the world champion in Go, some Asian board game, and he got beaten recently by Google DeepMind. They have created this artificial intelligent engine that beat him quite easily, I would say. So when this was announced, I was like, okay, AI seems to pick up now. It looks like it's becoming more and more mainstream. It's more available to everyone, not just PhD people. So I asked around in the company to see if there were any people interested in exploring this area. And I found one person. He was from Iceland. He joined the company like the week before. And I saw in his intro letter that he's been studying artificial intelligent game theory. So I didn't know what that meant. So I just went to him and like, do you want to do AI here at King? And he was like, he thought it was a joke. So I was like, no, I'm serious. So we teamed up. And so what we did then was, I asked him like, I saw that bot was mentioned here left and right. So I was like wondering what that was. Does anyone know what a bot is? Yeah, what's a bot?
It's a kind of robot, something like that. So I can do anything what you're supposed to do. So you code something and run something like algorithm or something. What should I do? And
Okay, so the short answer was it's a robot that can do anything. You program it and you can control it what the program should do, and that's quite right, I would say. On Wikipedia it said like application that performs an automated task. So what we did was like, okay, if we were gonna do like an AI bot, what should we, what's the low-hanging fruit? Where should we start? Who could have any use of this? And what we came up was like a QA could have use of this. If we would build some kind of testing bot that can test the game, that could help out. Level designers could have help with this to like evaluate the levels and test them that they're okay. And also the data scientist to go through all of the amount of data that we have and clean it up or analyze it and stuff like that. Now they do it manually, so they could be like having a good use of this. So what we did was that we were like thinking like, okay, how should we do this? So this is like a screenshot from Candy Crush. It's we were like, okay, let's say that we have this bot. How should he start? What should he do? So we were like, okay, in some way it needs to like have some criteria. And the thing that we were like coming up with was that this logic needs to be some generic. It should aim for making it work for not just one game but multiple games, and it should be like as little human intervention as possible, as automatic, self-going as possible. And so what we came up with, we were looking around for different algorithms, and then there's this algorithm called Monte tree search. And what this algorithm does is that it goes through all combinations. So if you give it some kind of option, it will go through everything. And then it will measure every option and see how good was this option to go. So then what you can do is that you can map up whatever application that you want to get an understanding of what paths are in it and which paths are good and which paths are bad. So what we did then was we tried this one out on our game. So the way it worked are that when we see different options in our game, like a move in our game is like you need to try to match at least 3 candies of the same color, then they will disappear. And that's like the main game logic functionality of our game. So what this logic then are doing are it's looking through the table and like, okay, where is all of the combinations, where it can go, and it doesn't know which one are the most favorable to take. So what we do is that we use this Monte tree search algorithm to go through all of them and play them through, and if it's successful, that path will get a higher score than one where you don't complete the level. And then what you can do is that you can you can tell this bot to like I want you to complete this game, or I want you to fail this game, and then with big chance it can find its way through either to be successful or not when it plays out the game. And I like visualizations. I'm not sure about you, but sometimes it's difficult to understand what people are talking about. So I asked the developers, the AI developers that we have, if they could visualize this, and this was the thing that they came up with. So what this is a level 13 in Candy, and at the arrow, that's where the bot starts. So all of these branches are different options that it can play on the level. And when it plays one branch, it goes down to the next level, and then you have options at that level, and then you do that until you play out the level. And in this picture, what you can see here is the green one represents when you completed the level successfully, and the red ones shows when you failed the level. You didn't complete it. Yes, a question?
The questions, the percent that you showed earlier, is this
Yeah. Yeah, so the question was the percentage that I showed earlier, what it represented. And I would say it represents success rate. How, you know, what's the favorable move here to take from a success point of view. And if you animate this, it looks like something like this. So this is like a real-time what the bot is actually doing. So if you ever wonder, these AI bots, what are they really doing? This is what they're doing. You give them, they're quite simple. What you do to a bot is you give it just input, like what are the valid moves and what are the, like, you know, criteria to complete the game, and then you let it play through itself. Right? So the takeaways from doing this Monte Carlo tree search that we got was that in this picture, in the middle you have this gray bar that represents the predicted, when we create a level, we have like maybe 20 moves. We think that the normal player should finish a level in 20 moves. So if he doesn't finish it in 20 moves, he fails. Or if he finishes it with less moves, then it's a skillful player, I would say. So what this bar shows at the bottom, that's human players. So when human players play, they pick up quite quickly and learn the game, how to play it, and are reaching this target quite fast. And what you can see, the other graphs are the bot. The first one is like a hard-coded one, where it doesn't take into account this Monte Carlo tree search run through of the level. And then the other three, the green, the purple, and the yellow ones, are different number of how long we have trained this bot to go through the levels. Because what you can do is that you can limit its search, because if it would search all combinations, it would take forever. So you need to do some kind of optimization and tell it like, okay, you have 1,000 attempts to try to complete this level. And if it doesn't, then it's like a fail, and then you try it again until you find playouts that are like successful. So what we learned here was that with this Monte Carlo tree search, somewhere around 150 attempts, the bot are like playing like a human, when the average players, when it comes to number of moves it needs to complete the level. So we were like quite excited about that, and we were like thinking like, okay, what more can we do to this? Because what we felt was that this took time from an optimization point of view. Like me, I want everything in real time. So, and this, what we figured out was, it was close to what the human plays, and you can limit it, the bot, how much it should play, and also, we wanted to get down the time, because it took like, around 10 minutes for it to play through. We want it in real time, so we want, as fast feedback as possible. So what we came up with then was an algorithm called NEAT. So what it is, it's like a reinforcement learning algorithm, and I think it's quite popular today. Most of the AI that are around today, I would say most of them are quite successful because of reinforcement learning. And the good thing with reinforcement learning is that you can learn while you're doing stuff. So what happens is, like in our case, when we do the Monte Carlo tree search, it doesn't know the different candies, how they work with other candies. It just see a blue candy, it just go for that one. It doesn't do any more evaluation. So what we did then with this NEAT algorithm was what you can do is that you can train it to learn which candies are most favorable together to play out. And the way we did it was that we created like an army of bots with different missions. Like one bot should just go for the blue candies. If they're a blue candy option, then it should pick that one primarily. And then we did that for all of the different candies that we have. And we let them play through, and then we picked the bots that perform the best. And then we crossbreed them. So we create a new, like a super bot that has the learning from the 2 previous bots into a new bot. And then we did that again until we get something that looks like something like this. So on the left side, you see like a Monte Carlo tree search bot. It just goes to every one of the candidates without any notion of, which one are good with other. But to the right, you have a bot where you use this reinforcement learning. There it can like draw some kind of, correlations between which candidates it should play out. And yeah, so here is like a breakdown of the logic. So what you can see here at the bottom are like a graph that represents the number of bots that are, running through the level at the same time. And what we have is like a criteria, like if the bot doesn't get better for like 15 attempts, it quits, then it's done, then it doesn't, run more simulation. And at the top, what you can see there is the best performing bot has at the red line, and the yellow are the average score of the bots that we're playing. And if you animate that, this is how it looks like. So what you see here is the number of bots goes up, and then they don't get any better, and then you restart, crossbreed, and play again until you don't get any better performance from this army of bots that are playing. And there you can see the best bot for one iteration. You can see there the nodes for that bot. So it's just some kind of visualization, so you get some kind of idea of how this works. Right. So the learning we got from this was that the light-colored graph, that was the Monte Carlo tree search, and the filled-in color, that's with this neat algorithm. So what we saw, that was the takeaway that we got, was that it was able to train itself much faster than the Monte Carlo tree search bot, because it knew better which path it should take through the game. So that was the learning we got from it. The downside of that was that that you can see in this graph is the green one represent the time it takes for the bot to get to the state it wants to make a choice, a decision. And the yellow one is the time the AI needs to compute, and the pink one is the time it takes for it to play out from the state that the game are in. So to play through like a level, it took like 5 to 6 hours to evaluate it properly, to get like to do all of this learning, training, and measure which players are the best. And in our world, that's not good enough. We want to get it down to real time, immediately. So the takeaway, I would say, that maybe can be good for you guys if you're going to try this out. Candy Crush was not designed to save all states. So when you execute your program, if you want to do AI, what you should do is you should try to save all of your states. So you can easily go to the state that you want to do a decision, and then you can roll back quickly, like instantaneously. That's the way to do it if you want to, nail this in real time. And also, like a lot of hardware helps. Good thing now is that Google, they have this GPU cluster where you can rent a GPU processing power, so you don't need to reinvent the wheel and build, have loads of machines. When we did this, we just had an old computer that we just had it running. And another thing, if you're going to do this for yourself, is your application should support to be run in headless mode. So you should have no graphics, because that takes too long time when you do the simulation. So you should have this boring command line prompt, and you see like executing and then done. So that's the biggest takeaway I would say. Okay, so what practical use do we have of this effort that we did? So what we did was we approached the level designers, and the way they worked today, before they had the bot, was they create a level, they let the testers play it, then they let the business people analyze the level's performance, and then they give feedback to the level designer, and then they tweak the level until they feel okay, this level is quite okay. And then we give it to our customers. We evaluate when they play, give feedback back to the level designers. Yeah, you were off a little bit from what we thought internally. And this process can take from days to weeks to get the whole loop because, a lot of people involved and, you know, everyone is not around all the time. So with the bot, what we've done is a level designer designs a level, he lets the bot play through the level, and he sees like within, I think we're down to 30 seconds now. So he get like an evaluation of the level after 30 seconds if it's like, you know, good, bad, or, you know, okay. And then we can just launch it to our end users. No need to analyze stuff like that. So that's what this has done for, you know, level design at King. So the level designers, they're super happy now. Before they were afraid that the bots would take over their job, but now they're super happy because now they understand, oh, we have more time to be creative and create a much more fun game for our end users. So the benefits, I would say, is like, from the level design point of view, they're happy. They have more time to do levels. They can do it faster and stuff like that. QA, the thing that we saw was that the bot found a lot of crashes that was really hard to detect because of like really, you know, strange edge cases that was like, you know, you can't reproduce them. But the good thing with the bot, you can, you know, save everything it does and reproduce it. So the game logic developers were super happy with this. And also the data scientists, they're like using it now to, you know, help them to clean data that got corrupted and stuff like that. They did do that manually before, but now they're like looking into like how can they automate that process with help of AI to do it for them. And the challenges to, if you're going to start with AI, the things that we, you know, the questions that pop up immediately are, okay, who should own this initiative? Should you have like a team or individuals? And who should sponsor it? And do you have the in-house knowledge, or do you need to take in like people externally? So that's a question you're gonna, you know, jump into immediately. Another thing that are important is that you should try to make the AI code agnostic. So it shouldn't depend on what language your program that you want to test are. So it's good if you think about maybe creating some kind of API. So you have like a, you know, like an interface, a generic interface. So you should think like that from the start. And also this headless thing. Can your application be run in headless mode, or do you need to, you know, recode it so it supports that? And a good way to introduce this is to dedicate maybe a hack day or a sprint to try this out in a small, you know, take some stupid simple case and try it out on that. Don't go like all in and like, you know, spend, you know, months. You really want to have fast feedback if it works for you. Maybe it is not the right thing for your organization or application, but I would, you know, encourage you guys to try it out at least. You will learn a lot, I would say. And another thing that comes for free are maintenance of this bot. Who should own that? What infrastructure needs to be in place? If you have like an API, then a lot of teams might be dependent on you to, you know, it should be up. If it's down, you're gonna get like the phone calls in the middle of the night. You don't want that. So you need to have like a, you know, plan for that. And also like, how should you continue the development of the API, of the AI? And the thing there is to build an AI that's easy to extend. You can add stuff to it, and then everyone can contribute to, you know, make it better, instead of you have like a bottleneck of people that are, you know, trying to maintain it. And if this sounded interesting to you, I guess you're going to have access to this presentation, and here's links to like papers that we have published. If you want to, you know, go down deep in on a technical level, and you can feel free to contact me and, you know, mail me, and I'll try to answer your questions as good as possible. And yes, this Slido, okay. So let's open this Slido thing, see if we can get that one to work.
Or maybe some questions.
So while we open Slido, before you, Anastasia talked about teaching testers to develop automated tests and coding, and now you say that it's you have an AI bot, and you hope others to contribute. So my question is, how easy it is to contribute to your bot, and are you not contradicting the previous story?
I would say it's super easy. You just, like at King, we have like an AI team. So they're like the one that are maintaining the bots. So if you have something, we just go and talk to them. So either they help you out or they help you to help yourself help you out. So that has not been a problem, I would say. Because I think the AI is like a new area and everyone is interested to, do something with it. So I haven't felt any problems with that so far, I would say. What? What?
Hello?
Okay. Hello.
How much time did it take from the idea to the stage when it was okay to use the bot?
Yeah, okay, so it took like 3 weeks, I would say.
It was pretty fast.
Yeah, because what we did, if you want to start this, what we did was we didn't have any people to do it. So we just took in students. So I just pitched to the student like, okay, if you can do this quick, we might hire you, and that's what we did. So they were like working like really fast. So no, it's quite AI isn't that super. It shouldn't take that long time. I think if you want to try this out, you should maximum give it like a month. If it takes longer, then you're doing the wrong thing or you have the wrong people doing the things. You should be able to evaluate this quite quick. The time-consuming part, I would say, is to figure out what's the best algorithms to use, because there's like a ocean of algorithms, and that's the tricky part, to figure out which algorithms are the best for you and how should you use them, I would say.
Okay, thank you.
Yeah, thanks.
So the job was done. Did you hire anyone?
What?
Не задавайте, пожалуйста, вопросы без микрофона, потому что их не слышно. Спасибо.
Ask later.
Have you tried to imagine other areas of gaming where such bots can be liable for create maybe for distance size, or have you any ideas?
Yes, one good idea. I think I'm not sure if you've seen it on YouTube yet, but DICE, they make this first-person shooter. So what they have done, they have created like AI bots that run around in the game, and they train it to become better opponents towards human players. But one thing that you can do with those bots, you can put on it like a QA hat. So it can run around there, and the only objective could be to like try, go everywhere on the map, do everything in the game, So instead of having an army of human people trying to do that, you can have like 1 million or 1,000 AI bots doing that for you instead. So that's like a low-hanging fruit, I would say, where you could use this.
We want to open slide, please.
Okay.
There are 3 questions.
Okay, should I read them? Okay, question number 1. Can this AI bot approach be used in console games? What do you think? And the answer is yes. You can use AI on anything that can give, it just needs like a input where it is like, what are the options it should do and what are the goal that you want to accomplish. That's the only input an AI needs. So what you need to do is like, like in our case, what we give our AI bot is like, this is the 5 options that you can pick. This is the number of moves that you have available to do this number of moves. And this is the score that you want you to try to reach. That's the only input you need to a bot. Then you can do it. So what you need to do, like if you have like, I don't know, if you work with Excel or whatever, maybe you should have like an input. The user can press 3 buttons and it can enter input in 3 fields, and the outcome should be like a sum that are like not, incorrect, something like that. And then you can just train it. So I think you can use it on almost anything where you have like input and you want some kind of output to it. Okay, the next question. Do you have manual testing of the game AI? Oh no, now the question disappeared, but okay. I would say the manual testing of the AI are the developers, the AI developers themselves. They test all the time when they create the bot because they need to prove that the bots are working okay. And I guess in the future, normal QA will move into that area, but I think it's too early now. I've seen some work being done where they try out to do manual testing of the AI logic itself. But the problem today, I think, is the tools, the testing tools are not there yet, where they're not mature enough to be able to do that in a efficient way, I would say. So, but I think we will get there. There are like work being done in that area. Okay, does bot use UI elements to finish a level? No, we run it in headless mode, so we don't, interact with the UI at all. You could do UI testing, but then you need to like use object recognition, and we have not explored that path yet. But of course, that's something that we have on our to-do list to do, to see if we can use that to help out to test more to like a real-life scenario. Okay, the last question. How would you approach regression testing for HTML websites? What would be the incentives for a machine learning algorithm? For the person that asked this question, please come to me after this. They are like a startup now by ex-Googlers. They're doing this. They have this testing framework to test websites with the help of AI. So if you reach out to me, I can tell you more about it. But in general, I would say the purpose of the AI is just to test through all of the buttons and options in a website with all of the heuristics that are known so far, like for security and functionality and UX experience, stuff like that. So please reach out to me and we can discuss it afterwards. Okay, another question here. What are the main problems, restrictions you see with the new testing approach? The thing, I think the main challenge are, it's like, I would say it's like a paradigm shift. It's like when internet came or when mobile phones became public available. I think the same thing goes with AI. Like the last 2 years has been some kind of start of a paradigm shift. And I think we all might not know yet how much we will be dependent we will be on this in the future. Or, in the future we will have like AI buddies instead of like humans that will work with us, robots or whatever. And I think it's important, that's a little bit why I'm here, to spread this knowledge and the experience takeaways that I have gained. And my hope is that some of you guys try this out and do the same if you have something to share, because I think we need to together try to nail this, because the AI, at one day, we don't want to go the Terminator way, and be run over by AI in the future. So we need to together try to, understand this and how we should use it in the best way, I would say.
Thank you very much.
Thank you very much.